Good evening, sir.
Good evening. How are you?
Fine, sir.
Great. Good to see you.
Thank you, sir. Good evening, everyone. It is my great pleasure to welcome our speaker for the next session, Mr. Abhay Shukla, sir, manager in the electrical oil and gas sector. He currently leads initiative at BARTEC Middle East in Dubai, a renowned German-based manufacturer of explosion-proof electrical system. Mr. Shukla sir brings with him more than 18 years of experience in diverse roles, including design, project management, and sales within the oil and gas and industrial segment. He is the specialist in the design application of electrical equipment for hazardous environment, complying with the both IEC and NEC standards, and is an expert in the electrical trace heating system for processing temperature maintenance and freezing protection. His impressive career includes the successful execution of the prestigious project for major industry player like and Saudi Aramco and PDO. Sir, we are honored to have you here to deliver a talk on advanced electrical system for oil and gas from hazards classification to trace heating execution. Your vast industrial experience and expertise in hazards area classification, protection system, and trace heating application will greatly benefit our participant by bridging the gap between the academia learning and real world engineering practices. We warmly welcome you, sir, and thank you for joining us today.
Thank you so much. First of all, I really thank you and appreciate everyone for joining this session. And special thanks to KIPM for arranging this session for everyone. And it's really an honor for me, to be here to interact with you. And the whole idea about this is basically to share the industry experience with all of you. So from my rich experience, maybe if I can contribute in learning and growth of everyone's, probably that will be of immense pleasure for me. So thank you so much for inviting me. And I will share my screen with you so that we can discuss about the topic. Yeah. Okay. So I will start with my introduction.
Yes,
My
sir.
name is Abhay Shukla, and I'm actually electrical engineer by education, and currently working as a sales manager and business development for BARTEC. BARTEC is basically a German company. They are active into oil and gas field. They are the manufacturer based out of Germany. And the main product domain is basically electrical heat tracing solutions. Apart from heat tracing, they are into explosion-proof component manufacturing as well. And the footprint is all around the world. We have offices in more than 45 countries, and I'm actually responsible for Middle East business for BARTEC. So, sorry. So I joined this company in 2018. So it has been around 7 years since I'm working with them. And prior to that, I was working with another company named Anvent. They are basically known for invention of the electrical heat tracing technology initially in 1970. So prior to that, I was working with other companies like Kalpataru and UPL. UPL is, just for your information, it is a joint venture company between Reliance Energy and NTPC. So I started my career with them as a project management professional, and then joined Kalpataru, an EPC company in power sector. After that, I got a very good opportunity earlier in Tyco Thermal Controls. So Tyco International is basically a US-based company. So initially, Anvent used to be Tyco Thermal Control. Later, Anvent acquired Tyco, so it became Anvent. So I started working with Anvent in 2011. So heat tracing at that time was new for me. So I started learning and then got interest into it, and then how things went well. And now, I mean, in last 7 years, I'm working with BARTEC as a sales and business development manager. So I got very good opportunity working with different companies in Middle East like ADNOC, Aramco, PDO, and KOC for electrical heat tracing solutions. Oil and gas industry, especially the system becomes more complex because of involvement in hazardous area, applications. When it comes to normal application, probably it is easy for you to choose any product whatsoever you want, but it becomes very important and very important thing when it comes to hazardous area application. So which equipment you choose for hazardous area, for safety solutions, that becomes very crucial. We will talk about that in the further slides. So just a brief about content summary. So we'll talk about heat tracing, as I mentioned, primarily. Then what are the types and applications of heat tracing system, which is widely used nowadays? So what traditionally have been the systems for process temperature maintenance, and what is the modern technology we are using right now? So we'll touch upon those topics as well. And then we'll deep dive into electrical heat tracing system, which is nowadays most widely used technology all around the world. Almost all industries, be it pharmaceuticals, oil and gas, petrochemicals, wherever it is, even in nowadays, for example, modern chocolate industries or anywhere. So we will deep dive into that as well. And then we'll touch upon self-regulating heating technology in detail, which is basically the core behind this electrical heat tracing system. So if you talk about in terms of percentage, around 80% of the systems are with self-regulating technology. So we learn about that technology in this session. And then, of course, what are the common applications, advantages, disadvantages, and we'll take up a question and answer session during the wrap up. So we'll start the session. So the first thing which comes in our mind when we talk about heat tracing is what is heat tracing? So this is first question which comes to our mind. So basically, heat tracing is an application of heat to a pipeline or vessel or any equipment whatsoever. The purpose is basically this is also called compensation heating, which means in order to compensate the heat which is lost to ambient, that is done through the heat tracing system. So in heat tracing, as you can see from this slide, we attach a specialized cable to the process pipes and then use a thermal insulation to conserve that heat. So whatever heat is lost to ambient, that is compensated with heat tracing system. So as you know, there are many ways how the heat is lost to ambient: by conduction, by convection, and by radiation. Generally, what happens, I will just give you background behind it. When it comes to process, any process, like any industry or oil and gas, petrochemical, whatsoever, when it comes to process, when the process is under operating condition, generally heat loss doesn't happen, or it happens very negligible. So there is no need of compensating that heat loss because there is no heat loss practically. But when the system is at stagnant condition because of any reason, could be due to maintenance, this could be due to maybe sometime there is a bypass section which is created for the emergency uses. So all those factors comes in picture, and in any situation, if there is any part of the section of the pipeline, vessels, or anything is in a stagnant condition, fluids under stagnant condition, and the process temperature, ambient temperature is lower than the process temperature, then the heat loss start happening. Let's take one example. For example, if the ambient temperature is 20 degrees C, let's say, and the process temperature for the stagnant portion is 40 degrees C, and the process is not in flowing condition, it is in stagnant condition, then the heat loss start happening until there is equilibrium between the ambient temperature and the pipe temperature, right? So eventually what will happen, the fluid inside the pipeline will get choked, so it will be solidified, so it will be very difficult to clean it, and then process will be totally blocked. then the real problem comes for the process operators. There the heat tracing comes in picture. So heat tracing is basically why it is necessary. It is necessary to compensate or to replace the loss heat which is lost to ambient, and to maintain the fluids or gases inside the pipelines or vessels or tanks at a desired temperature level, so as to avoid freezing, of course, and thickening of fluids. So the ultimate purpose is basically to improve plant operation, to prevent piping failure due to freezing or any reason whatsoever. So now we'll see what happens with the process pipe over a period of time. So these are two pictures which will give you a glance about when any pipe or equipment is heat traced or when it is not heat traced. So with this, you can see a clear difference. When the process pipe is not heat traced, then gradually the heat is lost to ambient and the temperature gradually comes down to a level of ambient. So the fluid becomes solidified, maybe within few hours only. But if we are providing heat tracing solution to the process pipelines, then the heat tracing system keep on maintaining by compensating what is lost to ambient to maintain the temperature throughout the operation. So it is ensured that the same temperature what is desired to keep the fluid at flowing condition, the same temperature is maintained throughout the operation. So that is the whole purpose. So you will understand what is the uses of this heat tracing system and how critical this system is when it comes to maintaining the operation of any plant, whether it is oil and gas refineries, any industry, or any petrochemical, pharmaceutical, or any industry. Now, when we talk about heat tracing, it is not complete when there is no insulation, because no matter how much heat you provide from outside, if there is no conservation of the heat, it will be lost to ambient, right? So insulation comes, it plays very important role in this. It actually preserve the heat. So whatever heat you are providing to the process pipe or equipment, that is protected with the insulation. With this chart, you will easily understand what is the difference when we are providing a thermal insulation on the heat traced pipe and we are not providing the thermal insulation. So if it is a bare pipe, there is no thermal insulation provided. The heat loss typically for a 2-inch pipe size, when you want to maintain it 55 degrees C temperature due to process requirement, and ambient is 0 degree. Let's take one example. Even though ambient is 20 degree or 40 degree, but still heat loss will happen because you need to maintain 55 degree. Your ambient is less than that. So of course heat loss will occur. So eventually over a period of time, the pipe temperature will reach to the ambient temperature. So if it is a bare pipe, the heat loss will be approximately 500 watt per meter. Imagine. So within few hours only, your pipe will become colder and all the fluid inside that will get solidified. But even if you provide just a 25 thickness of mineral wool insulation on the pipe, this prevents heat loss, and the heat loss comes down to 30 watt per meter. If you increase the thickness to 50 watt per meter, the heat loss comes down to 15 watt per meter. So imagine, in this situation, your 70-80% part is taken care by thermal insulation itself, right? But as you know, there is no insulation, perfect, which prevent from heat loss 100%. There is no insulation in this world. So there are different insulations which we use, but even though with the insulation, there will be some nominal heat loss happening, even with the insulation, because the K value of the insulation, even with the perfect insulation, it is K value is 0.027. Let's take one example, polyurethane foam. We call it PF. So in case of puff insulation, the K value is 0.022 watt per meter degree Kelvin, right? So eventually, of course, there will be heat loss happening. It will be very less, but gradually, probably it will stop, it will slow it. But after few days, because of that nominal heat loss, eventually the pipe temperature will become colder and will become same as ambient temperature. So, but thermal insulation obviously plays very important role. It prevents from heat loss, and then it actually reduces the requirement of heat tracing to major extent. And how we calculate heat loss, because there is a design engineering involved into this. So how we determine which heating system to be used, how much heat is required to compensate. For that purpose, we need to calculate what is the heat loss happening from any surface. So there is a formula 2 pi k delta T, T process temperature minus ambient temperature is delta T, divided by linear log d2 upon d1. d2 is the overall diameter over the insulation, and d1 is the pipe diameter. So what is the thickness of the insulation? That matters in this calculation a lot. So what we do, there is a software, we calculate the heat loss. What is the probable heat loss? Taking into account all the factors like K value of the insulation, what will be the minimum ambient temperature, what is the process temperature, desired process temperature, what will be the thickness of insulations, taking into account all those factors, and then we calculate the heat loss. So when we arrive the heat loss, what is the heat loss coming, then we decide which cable or which system we use to compensate that calculated heat loss. And then on top of that, we consider some safety factor, because there are so many factors which we cannot exactly take into account. So we keep some safety factor, let's say 10% or 20%, depending on criticality of the application. And then we calculate the heat loss, and then we decide which system to be used for any particular process in order to maintain the temperature. Now, what are the applications? So there are different applications, different uses for different mediums. Like for example, for liquids, the purpose is basically to prevent it from freezing and to reduce the viscosity, so as to keep it flowing. So for powders, basically the purpose is to eliminate from condensation from the walls of equipment that could actually potentially clog the pipelines. And in the gases, basically the idea is to prevent formation of hydration. So for different mediums, there is a different objective for the heat tracing applications. So we choose the application and choose the system based on the requirement. Now, I will give you example of some market sectors where all these special applications are used, mainly into oil and gas. 70 to 80% are used in oil and gas sectors, especially in upstream and midstream, downstream operations everywhere, be it storage terminals, refineries, distributions, and transportation. Because, when we talk about crude oil, let's take one example to make it more clear probably. When we talk about crude oil, which we often hear about, from media, news channel everywhere, crude oil is something at, let's say, 60 degree C temperature. Uh, the viscosity is less, so it's very easy to pump it and transport it from one place to another. But when the temperature goes down from 60 degrees C to 50 degrees to 40 degrees C, start becoming viscous. So it becomes very difficult for plants to basically pump it, to transfer it from one place to another. So it is extremely essential to keep the temperature of crude oils at always above 50 degrees C, bare minimum. So 60 is ideal, but minimum 50 is desired. So if you want to maintain the temperature to 50 or 60 degrees C, there has to be a system to keep it at the same level, right? Because depending on the location, if it is India, probably, of course, the less temperature we can experience is maybe 5 degree, 10 degree. But for colder countries, this goes to sub-zero temperature. So for different country, for different applications, the requirement get changed, become more complex, probably require more heat to compensate. But the desired temperature always remains same depending on the type of application. So most widely it is used in oil and gas industry, followed by chemical, pharmaceutical, energy, and aeronautics as well. So aeronautics, there will be someone who might be thinking why it is being used for aeronautics. This is basically this is used for basically for wings to preventing it from freezing. So there should not be any ice accumulated on the wings. So the heating cable is used to maintain the surface of the wings at 5 degrees C temperature, so that there is no ice accumulated during extreme cold conditions. So now we'll discuss about what all methods are there for providing heat tracing system. So traditionally, we have been using steam as a heat tracing system. Why steam? Because steam in some of the industries it is available as a default process kind of waste. So in those industries, it is quite easy to use steam as a easy way of maintaining the process temperature. But in the next slides, we will understand why steam is really very difficult to handle, and it is not safe in terms of operation. It requires huge amount of infrastructure, huge amount of initial investment, and periodic maintenance to keep it working. And when it comes to maintaining a precise temperature, it becomes very difficult with the steam to maintain a very precise and narrow band temperatures. So we will talk about the steam heat tracing system as well. There is another method which is called hot oil temperature heat tracing system. In hot oil, basically it's kind of we use mineral oils. We will talk about that as well in very briefly, but nowadays that system is totally obsolete. This is no longer being used anywhere. Uh, and then the modern technology, we will talk about electrical heat tracing system in the further slides, which is the most widely used technology nowadays in almost all industries. Okay. So heat tracing through steam. So on the left hand side, you can see the total process and system what we use in order to use the steam to maintain the process temperature. So of course we need a boiler and a pressure relief valve, and of course water treatment plant. So it's overall, if you see, it's a very complex system. It requires huge amount of investment initial, huge amount of efforts to keep it maintained, and maintenance is the key factor here, which require a lot of maintenance to keep it running. And the typical arrangement is like on the process pipe we attach copper or carbon steel tube, which is basically welded or strapped through the mother pipe, um, attached with it, and within that process tube we actually pass through the steam, and there is a thermal insulation on top of the pipe as well as the tube to protect the heat. So that is how the typical arrangement is. And steam heat tracing, as I mentioned, I mean, there are so many disadvantages rather than advantages. So steam, as in the picture you can see, it is really, heat transfer is the major concern in this case. Because, heat transfer coefficient, you really cannot precisely calculate how much heat is being transferred to the mother pipe from the steam pipes, right? So it becomes really challenging for engineering person to calculate how much heat is required and how much it is being transferred. And apart from this, it is useful only in those cases where steam is easily available as part of the process. Where steam is not available in the plant, it becomes even more difficult to create a new infrastructure to create a steam, right? And as I mentioned, steam is not useful for maintaining low band temperatures. It is probably useful for medium and high temperature applications, but not for, let's say, if you want to protect something from freezing, you need to just maintain 5 degree or 10 degree. You cannot do that with the steam. So it becomes very challenge to find out a solution for that. Disadvantages are more, like it is difficult to control, cannot be very precise. It's a very complex, and condensation and drain back and water quality, all those issues are there. As I mentioned, high installed and maintenance cost and high risk of injury, because steam is at maybe more than 190 degrees C, and it's very prone to leakage and accidents. So it becomes very risky to handle the steam. So that is why this system is now obsolete. No industry is now using steam heat tracing system to maintain their process temperature. Only where probably they are already having steam, it is a kind of wastage for them. They are probably somehow utilizing that for maintaining the process temperature. Otherwise, it is already obsoleted from everywhere. From this picture, you can easily understand, after several years of operation, all the pipelines and entire system get corroded. So you can imagine, it requires huge amount of investment for keep it running. You need to keep on replacing it every now and then keep on maintaining, require huge resources. So, and then of course, at the end of the day, the life is very less. Hardly maybe 20-25 years after that, you need to replace the system. So this is very costly solutions. And here are some pictures. These are real pictures taken from the sites. So a picture is worth 1,000 words. You can understand how difficult it is to contain it, right? So somehow people are managing it, but whenever we go to any customer, visit them, we try to actually convince them to use electrical heating technology, which is the latest in today's world. So here are some more pictures which will give you an idea about how difficult it is to maintain and live with steam tracing system. Now we'll talk about hot oil system. This system is totally obsolete. Nobody is using that. But just to throw some light about it, I mean, just I have mentioned typical pros and cons about it. So again, this is through the hot oil. So of course, heat transfer coefficient is probably better than steam, but at the same time, it's very difficult to handle the oil in day-to-day operation. And then there is possibility of solidifying and making it viscous. So it's very difficult to handle the oil in day-to-day operation. So practically it is not possible. That's why probably people have stopped using it. And again, precise temperature maintenance is very difficult in this case, and it is not environmental friendly at all. There is leakage risk, injury risk, and again, expensive equipment and complex system. So this system is no longer being used. I would say, hardly 1% industry is actually using this kind of system. Now here comes the electrical heat tracing system, which is core about this particular session. We will talk about electrical heat tracing system in detail. We'll try to understand what are the components in this system, how this works, what is technology, how it is economical compared to other two systems. So basically, electrical heat tracing system consists of not only a particular product. It consists of so many products, so many systems together. So that is why it is called a system. It's not a particular product, right? So electrical heat tracing consists of heating cable, which is the main component of the system, followed by the temperature controllers. Temperature controller depends on what kind of temperature we want to maintain in the system, how precise we want to maintain, and then of course power junction boxes, which is required in order to feed power supply to the heating cables, and then connection accessories. So this is a broad overview how the system looks like. So you can see here, there is a process pipeline with valves and flanges. And then we place a junction box on the pipe itself, which is to be heat traced. This is the pipe which is to be heat traced. We place the junction box there. take out the heating cable. It's a flexible cable, so it's quite easy. You can cut at side whatever desired length you want, and then wrap it around throughout the pipe. And by using end seal, you can terminate the circuits, and there you can get indication through a light whether the circuit is on, off, or faulty. So you can monitor as well within at real time. And then there are so many systems where you can monitor the real time temperature of the pipeline, set point of the process temperature, and you can control the system through DCS or control rooms at one place. And there are so many systems available nowadays where you can install a software on your PC and monitor your entire process, entire plant remotely from one place, and give a command to control or trip the circuit remotely. So you can really, on real time basis, you can monitor the temperature, you can do health analysis of the entire system on real time basis, and you can actually predict the maintenance requirement for the system. So, I mean, this is, although a whole kind of infrastructure is there behind it, but this is quite simple. You require just a simple distribution panels for feeding power supply, simple junction boxes, and easy to use cables. That's it. Not a complex system. So, why use electrical heat tracing system? Why there are advantages over other systems? As you know, electricity is everywhere and it is easily controllable. You can control it, each and individual circuits, each branch, each section of the pipelines independently. So that flexibility you get. Long line applications, cross country pipelines, it is quite easy with electrical heating system to maintain the process temperature of cross country pipeline for more than 20 kilometer. When I was working with Anvent, we did one project in Barmer for 680 kilometers of crude oil pipeline for IOCL. So we provided heat tracing on such a long pipeline, and that was Guinness Book of World Record. 680 kilometer pipeline, of course, not possible in a single circuit, but that was a different technology. And 20 kilometers we covered in a single circuit. Single circuit, when we talk about, which means one single junction box, one single AND seal, and one single system, which means one transformer, one panel, one junction boxes, and one controllers for the entire 20-kilometer pipeline. So imagine with this technology, how the overall heat tracing system for such a long pipeline made so easy that still it is running. This was commissioned in 2011 something, and it is running perfectly fine. No need of any maintenance, because 680 kilometer cross country pipeline running through desert, you cannot keep on going there for maintenance purposes. You cannot keep on monitoring those lines. So you need to have a system where you can remotely monitor the entire pipeline from one place remotely. So that is where this beauty of electrical heat tracing comes in picture. So no wastage of energy, as I mentioned, in case of steam or in case of oil, it's really very difficult. You cannot really calculate how much heat is being transferred to the pipeline and how much is getting wasted. But in case of electrical heat tracing system, you come to know with the design calculations. And because of course, the conduction is better in this case because it's a small plastic heating cable which is attached with the pipe. So the contact area is more in this case. So heat transfer is more effective. Will not burn out. We will understand this probably later in the next slides, why I'm calling this burnout proof. So even if you cross over heating cables together, it will not burn out. That philosophy we will discuss in detail, why it is safe. It is extremely safe solution even in classified hazardous area. In the next slide, we will learn about hazardous area. This is especially very important terms when it comes to oil and gas industry. So We will learn about it in the next slide. Low installed cost. As I mentioned, there is no complex system, very easy to install. There is no maintenance at all. So negligible maintenance cost. Once you install it, forget it for at least 20 years. So no maintenance cost, no impact on pipe elevation. So no matter how your pipe is aligned, whether it is on elevation, on underground or whatsoever, you can do this system. Whereas in case of steam, you can easily understand it is very difficult to attach carbon steel or copper tube with the process pipe and then keep it intact. So it's very difficult to maintain that. Whereas in this case, this being a plastic cable, it's very easy to attach it. And then precise temperature control and monitoring system. So there are different type of cables available for different type of uses. But most widely used cables in the electrical heat tracing system is self-regulating heating cables. This covers more than 90% of the applications worldwide. And this is so easy, so convenient that almost 90% of the plant and machinery are actually using this kind of system. Other systems like series resistance heating cable and mineral insulated heating cable. There is another one also which is called skin effect heating system, but probably we won't be able to cover skin effect heating system in this session. But skin effect heating system is basically applicable for very long length pipelines, like as I mentioned for IUCL Barmer pipeline, 680 kilometer. That was only possible with skin effect heating technology. So that is altogether different technology. That is only for more than 20-kilometer pipeline in a single circuit. But 80% of the industry requirements are fulfilled with self-regulating cable. In some cases, series resistance, and in few cases, mineral insulated heating cable. Mineral insulated is used for very high temperature applications, probably for aluminum factories, maybe wherein you need to keep the temperature more than 600-700 degrees C. There, mineral insulated cable comes in picture. For 1 kilometer to 2 kilometer pipelines, it is a long length pipeline, but not that long. So for those lines, you can use series resistance heating cables, but mostly for small lines, we use self-regulating heating cables. In this picture, you can easily understand how we select which cable to be used for which application. So it depends on the operating temperature requirement, and the length of the lines, as I mentioned previously. So there is a limitation of self-regulating heating cable, because when you are applying voltage to the heating cable, there is a limitation to the maximum circuit length. After that, because of voltage drop, you will not get the same power output at end of the circuit. So you need to keep the circuit length to bare minimum, where you can get the same power output throughout the length. So in case of self-regulating cables, this is the disadvantage, because because of the construction. This is a parallel circuit construction. So in this case, what happens, the circuit length, because of voltage drop factors, the circuit length is reduced drastically. So that is a disadvantage. That is the reason we use self-regulating only for small circuits, but not for the long circuits, long pipeline. So for temperature up to let's say 200 degrees C, maintain, and pipe length up to 235 meter, we use self-regulating. More than 235 meter to 1 kilometer pipe length, and up to 260 degrees C temperature maintain, we use series resistance cable. And for high temperature cables up to 1 kilometer, we use mineral insulated cables. And skin effect comes in picture only after 1 kilometer, but skin effect technology is not economical for less than 5 kilometer. Although it can be used for greater than 1 kilometer, but it is not economical for less than 5 kilometer single pipeline. Because of so many factors, this require Scott-T transformer, huge infrastructure for 33 kV distribution system. So it's a bit complex, but when it comes to cross-country pipeline, this is the easiest and cheapest solution. Now we will dive deep into self-regulating heating cables, about its construction, and then we'll learn about how it works, and then probably you'll be able to understand more about the self-regulating technology. So self-regulating heating cable is basically most intelligent cable of the entire heating cable family. As I have been emphasizing on this specifically, the word intelligent has been used because this regulates the power output in response to the temperature. We will learn in the next slide how this regulates the temperature in response to the regulates the output in response to the temperature. But first, let us understand the construction of the heating cable. Okay, so heating cable is basically construction you can see here. The main thing here is basically the carbon polymer core. Right, this is the base of this heating cable. So there are two parallel copper conductors, nickel-plated copper conductors, which are embedded into self-regulating polymer core, which is the main engineered polymer, which is used for the self-regulating property of the heating cable. And then we provide an inner insulation jacket for, of course, protection from the heat, and then nickel-plated copper braiding for the earthing system, and then outer fluoropolymer sheath for protection purposes from mechanical damages. So this is the construction of the typical self-regulating heating cable, although it varies depending on which kind of self-regulating we are using, depending on the application, depending on the temperature. Now here comes detail about the matrix or core we are talking about. So what is magical about this matrix, which regulates the power output with respect to temperature? So basically, this is a semi-conductive polymeric material, which is a polymer mixed with conductive carbon. So this has got PTC characteristic. So because of that characteristic, so basically, when the temperature of the matrix goes up, the resistance goes up, right? So that is what comes in picture. So what happens, you can understand it from this picture. So when the temperature of the matrix, temperature when it comes to the in contact with the high temperature, so when the temperature goes up, right? So what happens, the molecules, the electrons get agitated. So electrons move away from each other and they eventually break the electrical conductive paths. When the electrical conductive paths are broken, the resistance goes up. When the resistance goes up, the power comes down. On the other hand, when the temperature goes down, in the first picture you can see, when the temperature goes down, this actually creates more electrical paths in the matrix. When more electrical paths are created, electrons comes together, more electrical paths are created, the resistance goes down. When the resistance goes down, the power goes up. So that is why, this is the reason why this is called self-regulating heating cable. So it regulates the temperature with respect to the temperature, regulates the output with respect to the temperature. When the temperature goes up, output comes down. When the temperature goes down, output goes up. So that is why this is called self-regulating heating cable. So that is the whole concept behind this self-regulating technology. This was invented in 1970 by a US company, Radiation Chemistry, which is known as RECHEM. So when I started my career, I joined Tyco Thermal Control. So Tyco Thermal Control was basically owning up RECHEM brand name. So they were the inventors of this self-regulating technology in 1970. Since then, it is being used, and nowadays almost more than 80% of the electrical heating systems are with self-regulating heating cables. Now we will learn about benefits of self-regulating cable. As I mentioned before, um, it is very safe solution. No overheating. Why no overheating? Because there is a limitation in how much heat can be produced by a particular heating cable. This is engineered in such a way that maximum output per meter is fixed for every type of heating cable. There are cables which comes with 10 watt per meter output, fixed output throughout the length. But again, as I mentioned, there is a limitation in maximum circuit length. Let's say one type of cable can go up to 200 meter. So up to 200 meter, the power output remains same. If you increase the length to 250 meter, output will get reduced. So in order to keep the same output throughout the length, the maximum circuit length criteria has to be met. So no overheating, even if we cross over to heating cables, why there is no burnout? Because by concept itself, when you overlap two heating cable circuits together, the crossover, the temperature goes up on the crossover area. So when the temperature goes up, the power output goes down. So automatically that particular crossover section where the heating cables are touching each other, that becomes eventually colder, right? So there is no possibility that the crossover will turn into, eventually into burnout case. No, because the temperature will, power output of that section will come down. So the heat produced by the heating cable will come down. So there is no possibility that heating cable crossover will burn out. So it is extremely safe. No overheating, because I mentioned, because the heater output is limited to a certain limit only, to certain watt per meter only. So it's extremely safe. It's a parallel construction design. So it's a flexible, which means you can cut to any length, whatever you want, and you can install at site. Let's say your instrument, there is a level transmitter or level gauges, which is to be heat traced. You need to maintain at minimum temperature. You simply cut the heating cable, wrap around, give a power supply. Even there is no sensor required. So this is a major advantage. Self-regulating cable technology major advantage is there is no need of any controller when you are working with self-regulating cable. Why? Because this regulates the power output with respect to the temperature. So this is self-regulating. There is no need of controller. But still, why use controller? Controller is used in order to save the energy, because although it is extremely safe, even if you're not using controller, it is extremely safe. But there are some industries where you need to maintain the temperature in a very narrow band, right? For example, I will give you a few examples. For example, chocolate industry, you need to keep the taste and texture intact. So you cannot take a risk of even 1 degree higher temperature. So if you want to maintain the precise temperature, if something happens by accident, you cannot spoil all your production, right? So you need to maintain a very precise temperature for those high temperature sensitive industries. In those cases, temperature controller is required. But where the system is not so complex, not so critical, there you can use the system without any controller, right? And this is these systems are certified for use in hazardous areas. In the next slide, we will touch upon hazardous area classification as well. So probably it will be easy for you to understand what is all about hazardous area when I'm talking about hazardous area, how this is classified, and what are the things we need to take care of while designing the system for hazardous area classification. So hazardous area classification in oil and gas industry, or any industry for that matter, the area classification is divided into different zones and different gas groups. For gases, it is represented with zone 0, 1, and 2. And for dust atmosphere, like for example, sugarcane industry. So, or maybe where carbon dust is there in any industry, those comes in zone 20, zone 21, zone 22. For oil and gas, where gases are present, we classify it zone 0, zone 1, and zone 2. What is zone 0? Zone 0 is basically the area which is wherein the hazardous or explosive gases are present almost all the time during operation. like for example, petrol pumps, where the nozzle, when you are opening the nozzle to fill in the tanks of your car, that particular surrounding area from where the petrol is coming out from the nozzle and going to your tank, that area is called as zone 0, which is extremely dangerous. Even with a slightest energy, this will ignite. So extremely hazardous area. This is called zone 0. So only there is one particular item, one particular component which can be used in zone 0 is intrinsic safe components or electronic components, where the energy is so low that it will not cause the ignition of the gases. As you know, how the explosion occur. There are three, fire triangle you must be knowing. So there is a fuel, there is oxygen, and there is a ignition, right? So there is a safety protocol. So what we do in zone 0, we cannot use any system whatsoever except intrinsically safe apparatus, which are basically those apparatus which radiates such a low energy that it will not cause explosive gases to explode. So only those apparatus can be used, right? Electronic component, for example, but not mobile phones. As you know, mobile phone is strictly prohibited in on petrol pumps because of magnetic, because of electromagnetic radiation. This creates sufficient energy to ignite the gases present in the atmosphere. So zone 0 is so critical. Now we'll talk about zone 1. Zone 1 is the area where explosive gases are most likely to present during normal operation. Not all the time, but most often it is likely to present in those atmosphere. And then comes zone 2, which is less likely to present in those atmospheres. So zone 0, for example, is the area where actual fuel pumping or fuel is being handled. Zone 1 is the area adjacent to zone 0, but slightly away from that area, which is called zone 1. And far away from zone 1 is called zone 2, where it is less likely explosive gases to be present in the atmosphere. Same is the case with dust as well. So we classify zone 0, zone 1, and zone 2. So the heating technology, by inherently, it is increased safety approved by international authorities as an increased safety. We call it EXE, increased safety application, which means this will not cause ignition to happen. This will not cause any spark to happen so as to ignite the gases. So for zone 1 and for zone 2, or for zone 21, zone 22, all these system can be used. For zone 0, no heating system can be used. So for zone 0, if somebody coming up, there are some customers who comes to us asking for solution in for zone 0. So it's strictly no. So it is used for only zone 1 and zone 2 at max. There is a temperature class as well. We define as a T1, T2, T3, T4, and T5, and T6. So T6 basically 85 degrees C, T5 100 degrees C, T4 135 degrees C, T3 200 degrees C likewise. So from the table you can easily understand. This terminology is specifically used in hazardous area when we select which kind of equipment, which kind of component we are going to use in hazardous area or any particular area for that matter. There this classification comes in picture, and then we take care of all these classifications, approvals, and temperature class while selecting the appropriate cables. So you will come to know why T2, T1, T3 is important while selecting the appropriate cable, because there are some cables which can in uncontrolled situations, the surface temperature of the cable, because this is generating heat, so the surface temperature of the cable can go up to 200 degrees C. But suppose in your process plant, your I mean the fluid which is being handled, the ignition auto ignition temperature is, let's say, 100 degree or 85 degree. In that case, you cannot use the cable which is generating 200 degrees C of heat. So it is extremely important to select the right cable for the right application. That is why it is extremely important to understand the zone and T classification in when we deal with hazardous area applications. Now we will learn about different type of heating systems we have. So as I mentioned, depending on the type of application, depending on what temperature we want to maintain for any particular system, we use different type of heating technology. So like for example, this nomenclature is different for each manufacturer. For example, I'm representing BARTEC. So of course, PSB, MSB are basically brand names given by BARTEC. But when previously I was working with another company, there they were using different terminology like BTV, XTV, HTV, those kind of names they were using. But in principle, the overall technology remains same. They are just brand name. PSB is basically for very low temperature. This can go, I mean, the surface temperature, while maintaining the process temperature, the surface temperature of the cable can go up to 85 degrees C for PSB cable, which means we can use PSB only for T6 application, not only for T6 but T5 as well. Why? There is a thin line you need to really understand. See, PSB can give the maximum temperature of 85 degree, which means in worst case scenario, even if there is a runaway condition means there is no control in the system. It's a runaway condition. Your controller is failed and the system is continuously on. That is called runaway condition. So in runaway condition, the PSB cable can give maximum sheath temperature up to 85 degrees C, right? This is T6. In this slide, you can understand. PSB cable comes under T6, which means in worst case scenario, the maximum temperature generated by the PSB cable could be 85 degrees C, which means this is extremely safe for use where your system is certified for T3. Why I'm saying so? Because your system is capable of handling up to 200 degrees C. Let's say you have got certification for your process system to sustain up to 200 degrees C. So you can very well safely use T6 system, which can generate maximum up to 85 degrees C. But on other hand, if suppose your system is T6 and you are using a T3 cable, which can potentially increase the temperature up to 200 degrees C, it is extremely dangerous. So there this comes in picture while selecting the appropriate cable, depending on the area classification of a particular industry. So depending on the industry, depending on what kind of component they are using in that process industry, based on that, we select which system to be used. Right. And how we classify this? These are starting from low performance to high performance. When it comes to performance, I mean to say the temperature service. So from low temperature to high temperature. Increasing heating output, this is in order of increasing heating output. PSB can give maximum up to, can maintain up to 65 degrees C. MSB can maintain up to 135 degrees C. HSB can maintain up to 200 degrees C pipe temperature. If your process require to maintain 200 degrees C temperature, this cable can maintain up to 200 degrees C, which means this cable can be used even for 135 also, because up to 200 degrees C you can maintain. For HTSB, you can maintain up to 250 degrees C. So there are different cables, and all these cables are with different outputs, different construction, depending on the cross section of the conductor which is being used, the thickness of the matrix which is being used, the width of the matrix, the amount of material being used in the matrix, and all those factors comes in picture when we select the appropriate cable. So depending on the temperature, we select the appropriate cable, and of course the outer sheath is also made for that purpose. So if you want to handle high temperature, of course you need to have a very rugged sheath and very high temperature sustainable sheath. So we usually use fluoropolymer in case of high temperature and polyolefin for low temperature cables. Now, this I already explained in the previous slide, how we classify the cables, how the temperature classification works. So PSB is certified for T6. EX, you must be curious why EX is mentioned. EX is basically a symbol which is used for explosion proof or hazardous area safe components. So which means if there is a certification where this marking is mentioned, which means this product is safe for use in hazardous area. These cables are used for frost protection as well. Frost protection, or like for example, water pipeline. You want to prevent from freezing, so you can use very low output heating cable, which will just keep it warm to maintain just 5 degrees C. So even low temperature cables are available, like the gray one. This is very low temperature cable, which is basically used for frost protection only, which is used for cold countries, let's say. For cold countries, this very low output cable is used for water pipeline, for gutter de-icing, for any matter, for roof heating, for floor heating, for so many purposes. Now, from this picture, you can easily understand why self-regulating cable is so widely used. This is one of the example of the process pipeline. It's a complex pipeline. It's basically a tube. Imagine using a steam heat tracing on these complex pipeline. It's so complex, you cannot use steam heat tracing system, and you require huge amount of infrastructure, huge amount of labor to fix the process tubes, and system become so bulky. But see the skin effect, self-regulating cable. Self-regulating cable, it's a very thin cable. I will just give you an idea about thickness and dimension of the heating cable we are talking about. The width is, it is a flat cable basically. The width is starting from 10 mm up to 15 mm max, and the thickness is 4.5 mm to max 5.5 mm. So that is the dimension we are talking about. It's so thin, you can literally install those cables on even 0.5 inch, 1 inch tubes or process pipes. So it's very easy, it's flexible. You can install it very quickly, and contact area is of course better compared to steel tube installed on the process tubes. These are some more examples you can see. On pumps, how precisely and neatly this cable is used. This particular cable is basically the other cable, EKL, which is basically a series resistance cable, a thin cable, which is used for low temperature maintenance for long lines. This gives very low output. These are basically mineral insulated cables, which is fixed on very large tank, requiring very high temperature to be maintained. This temperature, this is all with self-regulating cables for storage terminals. This is also again mineral insulated cable for very high temperature requirement, which is fixed on the wall. And on a motor, you can see this example of other self-regulating cable fixed on the motor. You can see how the bending radius of this cable. This is so flexible, you can literally bend it up to 15 mm. So it's very easy to install no matter what surface you have. So as I mentioned, this is used for roof heating, for water pipelines, but those are low temperature heating cables used for domestic applications. Now the other heating cables I was talking about, I will just briefly go through it because these are anyhow very rarely used. But these comes in picture when it comes to long pipeline and temperature maintenance up to 260 degrees C. So the advantage of this system is basically this gives constant power output. This is a series resistance heating cable where just a single connector is there, and it gives a constant power output throughout the length. So of course, with the change in the length of the cable, the resistance varies, and then the power output also varies. But this gives a constant power output. In the other case, self-regulating, the output is actually variable. It regulates the output with respect to the temperature. In this case, it's a constant output, which means our power output doesn't get changed with change in the temperature. Then mineral insulated cable, which is used for very high temperature applications, like I mentioned in, let's say, aluminum plants, where you require 500, 600 degrees C or more than that. There, mineral insulated cables comes in picture. The advantages is that this is also again, this gives same output. So it doesn't vary with change in the temperature. This can go up to 1000 degrees C, very high power output, very long length, and this is applicable in case of high temperature and high long length pipelines. This is slightly inconvenient because of the construction, because the outer sheath is basically a metal. Sometime it is copper, sometime it is aluminum alloy. So the construction is very simple. There is an outer sheath which is made of aluminum alloy, stainless steel or aluminum, and then inside it there is a heating element and magnesium oxide as a insulation. This is inconvenient because bending radius is, not that flexible, so radius is less. So which means you cannot actually install it on maybe lines which is going through different curves. So this is for good for straight pipelines or maybe higher dimension pipelines, but not suitable for small pipelines. Crossing is not possible because this gives a constant output. If you cross over, accidentally touch two cables together, it will burn out. So this is need to be very precise when it comes to installation, and the person need to be very trained when it comes to installation. Now we will talk about connection equipments and controllers. So actually heat tracing system consists of, as I mentioned before, consists of several components. It's not just a heating cable. So heating cable goes on the pipe, then connected with different junction boxes, controllers, and different system. So heating cable, self-regulating specifically, regulates power output with respect to the temperature. So as I mentioned, there is no need of controller. But when it comes to saving the energy, because if you keep on heating system running, although it consumes less amount of energy, when it doesn't require to maintain the temperature, then it consumes less amount of energy. But when the amount of heat is required more, it consumes more energy. But even if there is no requirement of heat to the process pipeline, then also some amount of energy will be consumed because system is continuously on. So in order to save the energy, in order to precisely control the temperature for critical applications, we use controllers. So there are different controllers which are there um, with the different manufacturers. So some controllers we place on the pipeline itself. So it's kind of, I will show you in the next slide. There are some controllers which are smart controllers which can communicate through the Bluetooth. So you first configure it in the field, and then all the data comes through the software to the control room, through the Modbus RTU protocol, and then through RS-485 cables. So to the control room, and from there you can read the real-time temperature, the set point, what kind of fault. You can get fault alarm to the control panels, automatically trip, or there are two kind of systems we can use: fail safe, safe to trip, and there is another system where even if you want to keep it on, even if in case of fault, that is also possible. So there are two, there is a switch given. You can set for a switch off the system in case of failure, and switch on the system even if there is a failure. So depending on your requirement, you can set it. And then this is called smart devices for advanced monitoring and control of the system. So it becomes quite easy for maintenance and operations team to keep eye on the system, to keep it checked, and to keep it maintaining. And we'll talk about the software, because the system nowadays is so complex. The pipelines, the instruments, because it's not just about pipelines. There are so many equipments in the circuit. There are instruments like pressure gauge, temperature gauge, level gauge. There are so many instruments in the system. There are so many vessels, tanks in the system. It's because of complex nature of the pipelines, it's very difficult practically to do the design of the complete plant and provide them a solution of heat tracing. So how we do that? We have a software wherein we put all the parameters. We actually import the isometric drawings from the 3D model, plant 3D model, directly to the software. We get a complete overview of the pipeline, how the arrangements are, the isometric view of the pipeline, and then we decide how the circuit is to be formed, how a number of circuits is to be decided depending on the complexity of the pipeline, which section is to be given as a separate circuit, which section can be merged together to make a common circuit. This is all about optimization of the system. So we do design of the system through this software. So we import the complete isometric drawing of the plant into the system, into the software, and then we study there how the system is to be designed, and based on that we enter the process temperature, we enter the type of insulation being used, we enter all the basic details, and then it gives using the formula, heat loss formula, it gives the real-time output. And virtually using 3D model, we can literally see which pipe section is to be given what amount of heat. So that way we can actually design the overall plant at one place using the software and optimize the overall system. When we talk about optimization, it's about cost of overall equipment, total installed cost of the system, total operational cost of the system. So this way we can decide how many number of circuits are required, how many components are required to feed this power supply, how better we can optimize the power distribution system, which is required for feeding power supply. Depending on that, we can reduce the size of the transformer, we can use the number of distribution panels, controllers, and whole lot of stuff. And eventually we can reduce the number of cables, cable trays, and so many power distribution infrastructure we can reduce by providing optimum solution to the customer in the field. So that is all possible through deep study and through complex study using the software only. Okay, so as I mentioned before, the system is safe for operation in the hazardous area, but there is a system to certify. There is a body, international body, who actually certify the system for use in hazardous areas. So in our case, the entire system is approved by international bodies, and all these products are actually proven on international standards for heat tracing equipments. And this is just an example of certificates which is issued by the international body. We call it ATEX. IECX also we have. So these bodies are international bodies who actually certify your products for use in hazardous areas. So this is a combination of test and uh, uh, different international standards. We call it IEC 60079. So IEC 60079 is the standard which is used for hazardous area selection of equipment for use in hazardous area. So all these components are actually designed and used and certified following that international standard. Again, there is another international body which is IEC. So they give IEC EX certification, which is ATEX and IECX are most widely used all over the world. In India, there is a PESO certification. So PESO certification is basically um issued by the authorities based on ATEX and IECX only. So if you have ATEX certification from international body, you submit these certificates to authorities and they will give you PESO certification, which is used for Indian petroleum industries. So, but the basic concept behind those approvals are IEC, EX, and ATEX certifications only based on IEC 6007 ANI standards. Now, I think I have covered the complete session. Now I will take question and answers from all of you. So maybe let me share.
Dear participant, if you have any question, please ask.
Sorry. Yeah. Yes. So yeah, any question, please. I'm open for the Q&A session.
I think participant side there is no questions. Actually, the session is more related to the electrical engineering, but it also related to the mechanical engineering related to the heat transfer.
Exactly. Yeah.
Sir, we conclude that. Thank you very much, sir. On the behalf of organizing team and participant of this AICT ATAL sponsored FDP, I extend our sincerely gratitude to Mr. Abhay Shukla, sir, manager, BARTEC UAE, for delivering a very informative session on advanced electrical system for oil and gas, from hazard classification to trace heating education. Sir, your industry-oriented insight and technical clarity have given us a real-world perspective on how electrical safety systems are designed and implemented in complex industrial environments like oil and gas plants. Your practical examples and detailed explanation of hazards classification and trace heating applications have truly enriched today's sessions. We thank you once again, sir, for your valuable time, contribution, and sharing your expertise with us. Thank you, sir.
Thank you so much. Thanks everyone, and thanks especially to KIPM for arranging this wonderful session. And thank you everyone. Thanks all the participants. Still, if you have any question, I'm open for that. I hope you have learned something from this, and I was able to deliver in a better way. Probably I was able to deliver the matter, deliver it maybe more clearly. So I hope this must be useful for all of you.
Yes, sir. This is very useful for all of us.
Thank you so much.
Sir, please share the PPT to the HOD and
Definitely. Definitely. I will share it with you.
thank you, sir.
Thank you so much. Thank you. Have a wonderful day.
Thank you, sir.
Thank you.
Happy then.
Yeah. Thank you.
Dear participant, the feedback link for today's session has been shared in the group. Kindly submit it at the earliest. Validity session will begin at 5 p.m. The final test will start through the ATAL portal at 6 p.m. Please ensure your active participation in both. Thank you for your cooperation. Thank you so much.